Hello and welcome to part 2 of simplifying radical expressions. So we'll continue where we left off in part 1. We want to multiply 3 times the square root of 32. Although the square root of 32 is not a perfect square, there is a big perfect square that will go into it, 16. So I can simplify the square root of 32. Remember, you can use the prime factorization, or you can rewrite that with the biggest perfect square that will go into 32. Prime factorization, factor tree, or upside down division. 2 goes in the 8, 4, 2 goes in the 4, 2 times. We're looking for groups of 2 since we're looking at the square root of 32. So I have 2 pairs of 2's, so that would come outside of the radical with the 3. And then I had a 2 left over that did not have a pair, could not make up a pair, so it would stay underneath the radical. So 2 outside here, another pair of 2, so I brought another 2 outside the radical, and then this 2 that did not have a pair stayed underneath the radical. And I just multiply what's on the outside. 2 times 2 is 4, times 3 is 12, times the square root of 2. Again, you could have done that by saying 16 times 2 is 32, using 16 because that's the biggest perfect square that would go into 32, and then take the square root of 16, which is 4, bring it out, and you get the same answer. 4 times 3 is 12. So either way works. So 192. Again, I can simplify that. We're looking at the cube root, so this time we're looking for 3 of a kind. Since that's an even number, then I can divide it by 2. Still even, so I can divide it by 2 again. Still an even number, so I can divide it by 2 again, and I can still even, divide it by 2. Sorry about that, there should be a 6. So the prime factorization of 192 is 2 times 2 times 2 times 2 times 2 times 2 times 3. And we're looking for 3 of a kind since we're looking for the cube root. So I have a group of 2's here. That will be 1, 2 on the outside of my radical. I have another group of 3 of a kind of 2's here. So that would be another 2 outside of my radical. Then I had a 3 left over. So that would stay underneath my radical. 2 times 2 is 4. So my answer is 4 times the cube root of 3. Let's look at a couple more problems here. What about the square root of 100x to the 5th? Well, we know 100 to be a perfect square. The square root of 100 is simply 10. However, what about that x to the 5th? That is not a perfect square because we cannot divide that evenly by 2, by our root. However, since that 5 is bigger than the root of 2, then I can simplify it. So let's rewrite that. The next exponent smaller than 5 that is divisible by 2 is x to the 4th. So to rewrite x to the 5th in terms of x to the 4th, I would have x to the 4th times x to the 1st. That's the same thing as x to the 5th. Now, like we just said, the square root of 100 is 10. I can now take the square root of x to the 4th because I can divide that exponent by 2. It will be x squared. And then the x here will be left underneath the radical. Okay, so again, if the exponent is bigger than the root, then you can simplify it. What about the square root of y to the 11th? Well, I can't divide 11 by 2 evenly, but I can. The next number smaller than 11 that is divisible by 2 is 10. So I want to rewrite that as y to the 10th times y to the 1st. which gives us y to the 11th still. But now I can simplify y to the 10th by taking the square root of y to the 10th, which is y to the 5th. And the y to the first stays underneath the radical. Okay, and the last problem that we're going to look at is negative 2 times the cube root of 16 y to the 8th. So negative 2 times the cube root of 16 y to the 8th. So 16 or y to the 8th, neither one of those are perfect cubes. So let's look at 16 using our prime factorization. 2 would go into 16 8 times. 2 would go into 8 4 times. 2 would go into 4 2 times. And since I'm looking at the cube root, I'm looking for 3 of a kind for me to be able to bring a particular number to the outside of the radical. And I have a group of 2's with the 2 left over. So I'm going to bring a 2 outside the radical times the negative 2 that's already out there. Then I have a 2 that's left over. Now what about that y to the 8th? Well, I can't divide 8 by 3 evenly. So the next number is smaller than 8, that is divisible by 3, is y to the 6th. So you see I took 2 away from that 8. It doesn't go away. I just have to rewrite it there. So y to the 6th times y squared, that is still y to the 8th. I just split it up. And the reason I split it up is so I could take the cube root of that y to the 6th. So now I have negative 4 outside the radical. The cube root of y to the 6th, divide that. 6 divided by 3 is 2, so y squared. And then left over on the inside, I have a 2y squared. Okay, I hope you found the video to be helpful. Thank you.